Lesson 2, finding scale statement and solving for x. Okay, so when you're making a scale statement, it's important to note that you should have it in the same unit, and then when you have it in the same unit, you can find that actual scale factor. If you don't keep it in the same unit, it is also okay because you can still solve as long as you always write your units out. So we're going to show it in both ways. So the height of a man is 1.7 meters and his size on a picture is 2 centimeters. What's the scale factor? So I'm going to change this meters into centimeters to find it to be 2 over 170. And now we're going to do the scale size over the actual size, or the model size over the original, whatever you want to use. And our scale size is 2 centimeters and our actual size is 170, and because we don't have any, or because they're in the same units, we actually do not need to write that any units out. And then what we can do is we can also simplify this. So if I divided both of those things by 2, I would get 1 over 85. So this is the scale statement. If you put 2 centimeters over 1.7 meters and leave it like this and write the units, I'm also okay with that. But this is technically the scale statement. Okay, let's make a scale factor for this, which is easy because we can measure it ourselves. So I want you to pause it. These are equilateral triangles, so you can just measure one side and then tell me what you get. And you can't tell me because this is a video. So what you should have got is 5 centimeters and 2.5 centimeters. So if we're doing model over original, it would be 2.5 over 5. We can simplify that to be 1/2. So the scale statement is 1/2. And you don't need any units when they're the same unit. Okay, example 3. The length of the side of a triangle is 35 centimeters and the height is 15. You're drawing a diagram of this triangle and you know that the length of the triangle is 14. What's the height? Okay, so we're going to go scale over actual. And the thing that we have the same is the length and the length. So we know that the length of the actual triangle is 35 centimeters. And we know that the length of our drawing, or scale, or our model, is going to be 14 centimeters. So there's our scale statement. We know that the actual height of the triangle is 15, so I'm going to put that here. We do not know the height of the drawing triangle, so we're going to go x. Is this a problem we know how to solve? Yes, it is. What's it called? Proportional reasoning. How do we solve for it? Cross multiply and divide. So 15 times 14 divided by 35 equals x, and we are left with there's 6 centimeters for the height of this triangle. Example 4. A man who is 1.5 meters tall is standing beside a statue in the picture. When you measure the man, you see him to be 2.3 centimeters tall. You also see that the statue is 4 centimeters tall. How tall is the statue in real life? So we're going to go model over actual. And we know that the model size of the man is 2.3 centimeters over the actual size of the man, which is 1.5 meters. Now, I'm going to leave it like this. I'm not going to change the units because we're going to show how the units cancel. So we know that he measures and the statue is 4 centimeters tall on the picture. I know it's the model size, 1 because it's the picture, but 2 because it gives us centimeters, and these are both centimeters. Throw an x in there, we're going to cross multiply and divide. So we have 4 centimeters times 1.5 meters, and we divide it by 2.3 centimeters. And what we can see is these centimeters will cancel, and we're left with meters. And when we type this into our calculator, we get 2.6 meters. So the statue is 2.6 meters high, tall, whatevs. Okay, and just a reminder of why it's important to do proportional reasoning problems. We can use them for like literally everything. We use it all of the time. And one of my favorites is when we're dealing with distance and travel. And you can look up the video 60 miles per hour and watch it if you feel like laughing. But we're going 355 kilometers in 7 hours. So there's no way to make these the same unit, so you just write the units out. How far are we going to travel in 8.5 hours? Hours go on the bottom, x goes on the top. Proportional reasoning, so we have 8.5 hours times 355 kilometers divided by 7 hours. Our hours will cancel, and we're left with 431.07 kilometers. You're welcome.